Number 11 asks, at higher temperatures, most reactions occur more quickly because the activation energy decreases, more collisions have sufficient kinetic energy to surpass the activation energy, the energy of the reactants increases, or the energy of the products increases. Let's draw a generic energy diagram. Doesn't matter if it's endothermic or exothermic. And so we have reactants here and we have products here. And then we have the activation energy. That is going to be the activation energy of the reaction. So we know that collision theory states that in order for a reaction to occur, the reactants have to collide with one another in the correct orientation and with sufficient kinetic energy so as to surpass the activation energy. So what happens when you raise the temperature? Well, when you raise the temperature, it doesn't change anything about the reaction profile. It doesn't change anything on the energy diagram. The reactants and the products sit at the same energy. That's not going to change. The activation energy is not going to decrease. The only way to decrease the activation energy is to introduce a catalyst. So we're not talking about that here. All we're saying is that we're increasing the temperature. So when we're raising the temperature, what is temperature? It is a measure of the average kinetic energy of the particles in a system. So if we're raising the temperature, all of the particles are moving around more quickly. And so if they're moving around more quickly, they will collide with greater kinetic energy. Each collision in the system has a greater probability of colliding with enough energy so as to surpass the activation energy. So this is going to be B. At higher temperatures, a greater fraction of the collisions will have enough kinetic energy to get over the activation barrier. And so the macroscopic result of that, when we're looking at a reaction vessel, it goes faster because instead of, say, 10% or 20% of the collisions having enough energy to get over this activation barrier, instead, they're moving so much more quickly that, let's say, 70 or 80% of the collisions have enough kinetic energy to get over that activation barrier. So the end result is that the reaction goes faster. So that will be B.